Okay, I'm recording again. So, okay, I can share here. You can see what you did here. So can you, one of you, Miguel or Diego, one of you, can you talk about it as I'm sharing my screen?
Yes. Well, first we upload the table. That's the error that we have last time. We equal to table read table. It doesn't work. I don't in the computer in this computer, but in the computer of Miguel it actually works. I don't know.
It happens to me also, and it's because the address changes every time. So you need to, whenever you are using the file bin, you copy that data, you paste it, and you will be able to use it. I think, for example, if you copy and paste that address that you have right now, well, in this code, it will redirect you to like the file bin page, but you need to take the new address. It happens to me, and yeah, I needed to constantly update it. I don't know why it doesn't get static.
Yeah, it happens to our group also. We have to re-upload it every time we want to use it.
Okay.
Okay.
Okay. Anyway, okay. Yeah. So anyway,
Okay. Okay. Well, we first download the table. We did so many so many exercise. Okay, then I don't see. Okay, see the error.
So you couldn't run it at all, like successfully?
We upload a new table for better results, for more recent results, but it doesn't work with the new table.
Okay. So anyway, even if your data change when you're running it, when you're getting all your output, okay, and when you submit the okay, I'm going to see exactly that view. So it's not going to change here when I see, for example, this is exactly the way you submit it, because it means you get the error, you follow it up, and then you got error, then you press submit. So that's what I did.
I submit an exercise with the graphs, but I don't know why it is there.
No idea, honestly.
I
think that Diego's submission overwrite my submission.
I don't know.
It was at 3 p.m. I think so, right?
It's like 12 a.m. Wednesday.
See, mine was at 11 p.m.
Yes.
Let me see. Okay. Yeah, this is the only submission I got, I guess. So I got the other submission, but they're all showing basically the same error.
It was the one below, I think so.
10 p.m.
There's a lot of there.
Oh, okay. Yeah. Okay.
Yes.
But okay, guys. See, this is actually good case. You know, they did something. They did the submit. Okay, these are what they did. They submit, but maybe they keep working on it. They face error. But what did they? They submit that error. Okay. So what I'm going to see here when I check my OKPy is your last submission. Maybe your previous submission is correct, but if your last submission is wrong, I'm going to basically grade that, because I'm not going to the history and check all the 20 submissions. I'm going to just check the last submission. So please take care of that. So okay. So can you tell now what you did? Very briefly, like in 1-2 minutes.
Okay. You explain it, Miguel?
Yes, we made some tables to show all the cases in the world, the confirmed cases, the dead cases, and the recovered cases.
Okay.
And we also made a graph to show the three graphs in one graph to compare them. Is that graph?
Uh-huh.
And after that, we did the same, but by country, with the top 10 countries with cases, deaths, and recovered persons, people.
Okay, these are the confirmed cases. Okay.
Yes. And we also map it, but it was the error.
Oh, you put, okay, I got it. You tried to put it on the map, but you got there. Okay, thank you. No, that's clear now.
We did.
I'm going to briefly go through all of them, so later I'll check them more basically precisely. So this group,
I think that, yeah, that's mine.
okay, can one of you talk about it?
Yeah. So
But
basically,
if you wanna, it would be better if you share your screen, then walk us through that.
yeah, but I can't open virtual tech. I don't know why. So
Okay, let's do it here. So try it. I mean, now next week there's basically Semana Santa. You're supposed to be home, not
yes,
doing traveling, so you have a lot of time. Try really it take like maximum 1-2 hours installing Jupyter in your local host, even faster.
okay.
Okay, so
Yes.
try to do it in your local host, then you won't be having any problem with these things. Okay, so can you explain what you did?
So we did several graphs just trying to compare the rate at which the virus is spreading per country. The initial problem was how the data was set in the table because we had one column for each day since the infection started. So first we showed just this graph of Mexico, and we can see it's like an exponential graph because it's peaking. But then if we compare it with the next graph, which is in China, this was only of the first state of China that got infected with, which was Wuhan, I think.
Mm-hmm.
We can see that.
Well, the state is Hubei.
Hubei. Okay. Yes, state.
Okay.
So it's really nothing like similar because, as you can see, China was like a giant peak, and Mexico is still, well, at least with the data we have, it's still in early stages, maybe, but it could get well, much worse. And other countries that were like very infected were Italy and Spain. So we also compared it with them, which are still a lower rate of infection than China, but still like extremely high. And it's still nothing compared to Mexico, like what's everything that's.
Mm-hmm.
So yes.
Okay, for example, like let's talk about this. For example, this graph. Okay, this is an open question for everyone. How can we conclude anything from this graph or not?
It's at the same time it's in the same timeline.
So this is the date. This is from February, March. These are the dates. This is for China. I assume this is the infected case, right?
Yes, it's the same date,
Yeah.
but since China started first, then there's no activity in Mexico while the virus was spreading in China. That's why it started growing later on.
Okay, so the question is, this graph gives me information or not?
And kind of.
So can you drive some conclusion from this?
Well, that China is where the infection started, and it didn't arrive to Mexico till way later.
Okay.
So maybe if this has started when China is starting to get the infection, and when Mexico is starting to get the infection, maybe we could see more clearly how we're going compared to China when things started on both of us. And right now, what we conclude from here is China started first. So, yeah.
Yeah, it's like as Daphne said, it's like, or Humberto said, it's like it tells us China started first, Mexico later. It's what I see based on my humble opinion is like it doesn't tell us new information. It's like it's something that could be said in a sentence without figures. But then comparing these two, yes.
Yeah, to be honest, we wanted to match from the day 0 in
Okay.
which each country had the first patient confirmed, the first case, but it was really difficult.
Okay, yeah. Yeah, maybe you had to modify the tables, like, yeah, true. And this one is like country region, Italy, Mexico, Spain. More or less the same thing again, what I've observed here, like, because we're not, another thing is, for example, comparing this, even if you put the first date, okay, you need to do one more thing. You need to, what I would do number of infected people per capita, because China is 1 billion people, Mexico is 130 million. So you cannot compare a country of 1 billion with a country of 100.
It wasn't of all China, it was just of the first state in which the...
Yeah, so, okay, then you're comparing the first. Okay, if you consider, for example, again, it would be much better to calculate it per capita so you can get a fair comparison, okay? So this is the Mexico from the start till March 30. Okay, that's scary. Okay, guys, thank you. Let's move on because I don't want to spend too much time here. Is submission?
Hello, teacher.
That's us, teacher.
Okay. Fran, you want to share your screen or you want to walk when I'm sharing mine?
Yes, I can share my screen.
Okay.
Yeah, so first the first idea we had was to predict how the infection was going to be around the world, but by using an exponential function. But as we found out, some countries follow that function in their infection rate. At some point, others don't at all. And we found out that we needed to use a differential equation model to do this. So we threw that idea to the trash can. Basically, we did we did two things at last. We first did the comparison of the exponential graph with the real data for each country.
With the values that we have from the data set.
Okay.
Yeah. Well, first, I get the table from the repository you gave us. So since it's taking the data from that URL, every day is updating. So like every day we'll have the information that is registered until that day.
So, okay.
Yes, maybe I can delete this.
Yeah, the first idea, and then we also did a map in which with a slider for each day you could see in each country how the infection was going with circles. That's why you see the volume and that. The first idea was to use prediction, so we used the slider. So we would have using a slider to show the real data, and after that the prediction with a map. But as we figured out, the prediction wasn't going. We weren't able to get the predictions right, so we just got the map and the exponential comparison for each country.
But you didn't draw like a graph?
Yeah.
Yes, we did. The problem is that I don't know why there you can't see it, but I'm trying to run all the cells here so I can share my screen and show you what we did.
So should we
But
wait? Should we come back to you later, or?
No, I have everything here, but I cannot share the screen because you are sharing yours.
Oh, so if I stop sharing, you can share?
Yeah.
Okay.
Okay. Just now I can share. Here. Can you see it?
Yeah, yeah.
Okay. Here
Yep,
is
that's
the
it.
map.
Mm-hmm.
So with this slider, you can go through the days.
Mm-hmm.
Yep.
Every day you have the circles drawn, and if you check the label of that circle is like the country.
Mm-hmm.
If
And
we
the
have
total.
if we have the region, also the region is specified, and the total is the total for that country. So, for example, if you check each point of China, will have like the whole country's the whole country register. So then, if we check like this day, the 33 information, we have different.
So the size doesn't have anything to do with the number, right?
Yeah.
Yes, we tried to do it with a logarithm function, because if we use the real number as the radio, we had like very huge circles and the data was not so clear.
Okay.
But
yeah,
if you
and
see, if we
also go on.
Okay, if you see, if we go through all the days, circles are getting like bigger.
Mm-hmm.
Because there are more cases.
Okay.
And also, we had a little bit of trouble using we know that data science, the package, has a real nice way to draw the maps with the circles, but we found out that that those maps that we were drawing didn't have the labels on each circle, so we used directly from the volume package, which is inside the and also we have the exponential graph.
Here we have the exponential graph, but as you can see, for example, here in Guatemala, this is like the actual registers that we have, but the exponential function is like going so higher. So for some countries, like this gives us like wrong answers, like wrong predictions. So that's why we decided not to use this approach.
Okay. Okay, thank you. So let's share screen. So let's move to the next group. This was you, right? Yep.
Yeah.
So this group. Anyone here from this group, or should I search? Juan Jose? He's not here. Jose Manuel? Okay, so wait. So no one from this group? Let's go to the next one. This group? Cesar Augusto?
We here. It's our team.
So, want to share a screen?
Share a screen? Yes, but I'm gonna reconnect because I am on the cell phone right now. So I'll be back.
Okay, so I move to the next, then we come back to you. This group?
Sure. Let me.
Okay. You want to share your screen?
Yeah.
Okay.
Can you see my screen?
Yes.
So here we get a table. I already loaded because it also you need to constantly refresh the link, and we get the number of cases and deaths per day in city in country. And so what we did is get this table. I did it for another thing right here, and we get the total number of cases. Here you can get the cases per day for in the country you want. For example, let's get Spain, and you see yesterday there were 812 deaths and 6398 cases. And we also, well, this is the cases and deaths total per country. And here we did a graph that gives you the cases and deaths, the increase of cases and deaths per day in the country with. For example, let's get Spain. And you can get, for example, here's not happening nothing. You can get the last, I don't know, 36 days. And you can see the number of cases and the total number of deaths. And also here we will display the info for that specific country. And that's what it will.
That's perfect. Can you put it in Mexico and see what's happening here?
So a little about 1,000 cases and 28 confirmed deaths.
Okay, perfect. Yeah, thank you. It's well done, nicely presented.
Thank you.
Okay. Let's go to the this group. You're back, Cesar?
Yes, I'm back. I'm
Okay.
gonna share screen.
Okay.
Okay, I think you have the share screen now.
Okay.
Okay, so what we wanted to do in this first step of the homework was to know if the actions taken by the Mexican government had been correct according to the data that we're going to see. And if the actions that have been taken are being taken right now are have the right time, if they are in the right moment. So the first thing we did in this part was to separate each country and each case and each history of cases. This is only going to be the confirmed cases, not the deaths. And we are going to use 4 countries: Mexico, Italy, Spain, and USA. I did not decide to use China in this comparison because I think this information is more reliable than the one that we got from China. Okay, so this first plot shows us how the contagious people have grown since the beginning of the record of the first table. So it has been around almost 70 days from the first record. And as we can see, the first country infected, as we know, is Italy, then was Spain, and after that, USA. And Mexico still is not comparable to those graphs because we are just beginning the infectious phase. As you can see, USA has, even though it started a little bit later than the other two, it has ramped up to an extreme level, surpassing Italy and Spain. But this is not a fair comparison because the virus came in different times for each of these countries. There is no a point of reference in that graph. So what we did was to get the first day for each country. And with that information, we can plot a more comparable graph between those countries. This is it. As you can see, the rate of infection for Italy began to ramp up about a month after the first infection was discovered in the country. And in Spain, it took a little bit longer, 40 days. And in the United States, it stays restrained until the 50 days passed. Mexico is about a month into the coronavirus. And as we can see, I don't know if you can, but if we zoom in, there is a little bit of curve that is being generated in this day, a month after the first case was confirmed. And there's also another interesting point that we can see is around here, the 56, the 57 day in the United States, where it seems that it passed from a curve to a almost straight line to the top. So first, I decided to investigate a little bit on that, and well, I tried to plot, zoom in the plot, and yes, it seems like it's about the 56th day after the first confirmed case in the United States. That will be the 18th of March of this year. And after reviewing some news, I found that in February 28, the cases in the United States stopped being linked from international travels. So now it's local infection inside the United States. So in this moment, the infection is supposed to grow more crazy than before. And as we know, the phase for detecting new contagious people for COVID is about 10 to 15 days. So if we know that these people, this information was from February 28, and also we have another new from Box that says that March 30, and it will be a race on cases in the United States because better testing was being deployed around the whole country. So this led to think that the new quantity of cases that has been reported since that day was linked to a local infection in the United States, that it was no longer for international cases. And the testing and the protocols to detect these people has been increasing in the quality, making it more people had been detected and less has been over the radar. Also, returning to the graph, the day 30 for us, it seems like a very important day for Mexicans because it's also the day where local cases has been announced by the government. So it's no longer a phase 1 of the pandemic. And that means that maybe we shall be seeing a future similar to the United States, that if the second phase is right here, we're gonna have a curve that is more like a straight line to the top if we don't have if we don't do the recommendations that they post. And I think it's a very important day. I think after reviewing this information, they are doing the necessary steps right now because it's like before the chaos really begins. And I really hope that we all do those recommendations. We also have a second part that is going to be explained by Ricardo.
Okay, thank you.
So basically what I wanted to see is how was China, because it originated from there. So basically what I try to see is in the different states that China had, how it was growing. And now that we know that the last patient from COVID was released from the hospital, to see if by any chance it had decreased. So in that table, we can see how it keeps increasing in big numbers. And then, however, the latest data the table has, it is still on the top. So so we concluded that from there is no data that prove that the cases reduced from there.
Mhm.
And that was basically it from the part of China.
Okay, I think that's everything.
Okay, guys, thank you so much. That's pretty, great observations was there. Very interesting. So let me back to wait. So let's go to the next group. So this one. This group. David Emanuel.
Hi, and that is us. So first of all, I want to share a link. The analysis that we did, maybe I can share my screen.
Okay.
So this is the tables we made for this exercise. But before beginning the analysis, I wanted to share a link through the chat for a video that we found making a similar analysis of the cases. Oh, it seems I can open the chat. Well, the point that they make in the video is that something that is not being analyzed truly up to date is how far are different countries progressing in their journey through the different stages of the COVID-19. So what they did is made this graph right here that basically plots in a logarithmic scale the ratio of how many new patients are discovered every day in a country compared to the total cases in that same country. And that way we can see when cases stop appearing and when the illness stops progressing. For example, here, the biggest drop you see here is China. So as we can see here, China already has like gotten over the illness. And other countries here that we have, USA, Spain, Italy, Japan, even Mexico. One thing I have to make clear is that we did not use the dataset from GitHub. We used a different dataset from a page called Our World in Data, which is much smaller and not as recent. So for example, Mexico only has in this dataset like 53 cases registered. And in the other...
So what are the data in the x-axis? 10 to the power of 1?
No, not really. Not really. That's why most of the results you're going to see here come from the data from bigger countries like US and China, because they have
No,
the
I mean,
most
for
data.
example, what does it mean? In the x-axis, you have 10 to the power of 1, 10 to the power of 2.
Yes,
10 to the
it's
power of...
the
Okay.
x-axis is the total cases registered in that country, and the y-axis is the new cases. And it's a logarithmic scale to see the rate of growth of the rates of new cases.
So y-axis is the new cases.
Yeah.
Yes.
And x-axis is the time that's passing.
No, it's the total cases that have been registered in the country.
10 to the power of 5?
Yes.
Okay.
That's what the that is it too.
Okay. Okay.
Okay.
Uh-huh.
So this way, when a drop registers for the graph of a specific country, we can see when basically the country has passed over the pandemic.
Mm-hmm.
This one below is a similar thing, but for the deaths in the country, the newly registered deaths in the y-axis against the total deaths in the x-axis to see a similar kind of progress. In both graphs, we can see China has already stopped the growth.
Mm-hmm.
So even since the scale is logarithmic, even if the growth here seems linear, it really is exponential. It's only the way we are seeing it in the graph. So
Mm-hmm.
a drop means not that cases have stopped appearing to a halt. It only means that it's no longer growing, it's stabilizing.
The rate is reduced, right?
Then below, we made some graphs of the countries we were plotting in the graphs above for how many tests have been performed in the country for that dataset, and a relation between the amount of tests performed in the country against the number of cases that have been reported for that country. And that we can, in some ways, see the veracity of the statements of that country. For example, in China, China is one of the countries with the most cases, but since it's also one of the countries with the most tests, we can in some way conclude the data coming from China is somehow more trustworthy than from other countries, for example, for Mexico. Since in this data set, even if Mexico only has 53 cases reported, they have no tests. And those are basically the different stages of analysis we try to do.
Okay, perfect. Yeah, actually, I was going to talk about it. The number of the cases versus the confirmed cases you have, definitely they go hand in hand. That's why we see in other example that they show other students that their case in the US is growing so fast because they started testing massively. But I have serious doubt that that's the case happening here. I don't think they tested enough. So I'm wondering, or I'm worrying that there are way more cases in Mexico have not been tested.
Mm-hmm. And the reason we decided to use this data set over the other one is because the way the tables were formed, the other data set had, like we already saw, a different column for each date. And in this one, it was a different row for each date. So that way, it was easier for us to process the data in the way we wanted to.
Okay, perfect.
To draw our conclusions. But in the video, I want to send through the chat when I stopped sharing my screen.
Okay.
They did use the dataset from the Digitof, so the information is a lot more complete.
Okay, yeah, please send the link. If we have time, I'm going to share with everyone.
Okay, thank you.
Thank you. Thank you, guys. So let's go back and see who left. So the last submission, we have one more here. So
Bhakti, just a really quick question because I don't see our submission, but we send it on Friday.
Okay, let me see. Oh, sorry, it's not all of it. So it's.
Oh yeah, okay.
Yeah.
Now I see it. Thank you.
Yeah. Okay, so let's go with this group.
I'm gonna share the
screen. Okay.
Wait, Can you see it?
Yes, we can see.
Okay.
Okay, so we showed a lot of the things that other teams showed.
No worries. It's
Yeah, so those are just the tables. We used a table that showed the situation on the day. We selected just the day that we last modified it, so it was the 29th of March. It was like 2 days ago, I think.
Okay.
And that is just a little table showing worldwide how many total confirmed, total active, total recovered, and total deaths you have. That is a little graph showing the situation change in 1 day. So we took the 28 and the 29 to see in the top 10 countries that have more infected, how the situation is growing. And that is just another way of visualizing it, but it's the same data. We compared different things. We compared the 10 countries with more deaths, with more confirmed cases, and with more recovered cases. And we saw in the graphs that sometimes they were not the same 10 countries.
Okay.
Yeah, those are just graphs of the confirmed. That's what I was showing. Like, for example, the most confirmed are US, Italy, China, Spain. But then in the most deaths, we can see that Iran is in 4th place. And in the most confirmed, it's not in the, it's like the 7th, I think, 6th, 7th. Then we found in the next table that is down the countries that had no deaths yet. So they have active cases, but no deaths yet. And we see that Latvia is the one that has the most cases without any deaths. It already has 347 confirmed cases and it hasn't had any death. For example, I think in Mexico it was around the case number 80 when we had our first day. Okay.
That's interesting observation.
It's the only country that we've found that has 1 case confirmed, but also 1 case recovered. So in the actuality, they have no cases. They had the coronavirus, but it was cured, so they have no cases right now. Go lower. We use the datasets to make some maps. We commented them because when we ran it, it ran, but when we tried to submit it, I think because it was, I don't know if it was because it was too heavy or something, but we had trouble submitting it. And then we took another data set. Stop. Sorry, we took another data set that just showed the cases in Mexico. It was actually a little bit hard finding a CSV file showing the different states in Mexico, but we found that one. It is not that up to date. I think it is a little bit not updated, but it's okay. We can see that the state with more cases is Ciudad de Mexico, then Jalisco, then Nuevo León. And those are the cases with the states with the less cases. We show in the graph the states so you can visualize it easier. And with that information, we also saw that the cases that were reported, a lot of the people had traveled, and we can see where they came from before they were diagnosed with coronavirus. So the most people came from the United States. And from the Mexican data set, we also analyzed how many were male and how many were female. And we can see that there are more guys right now infected. And we also saw the ages that they are. So the more that the data set had are 30-year-olds. They are 14 people with 30-year-olds and 35. And you can see the data of the ages.
Oh, interesting.
And I think the last one is just a graph showing all of the countries that are infected. Yeah, I think that was it.
Okay, thank you. It was interesting that you look at Mexico data more detail. Yeah, thank you. Thank you for sharing. So you can stop sharing so we can move to the next group.
How do I stop sharing?
Pardon?
Oh.
So let's move to the there are single submission. Oh.
Yeah,
Okay.
I didn't remember how to add someone.
I think it would ask you that you have to select or you have to invite. So you would need it to basically put the email address of your basically project member, invite. If they receive an email, I think, then they accept. But they would be added to the group. But anyway, let's move. This is you?
No.
Okay, who is this project belong to? So you want to share your screen?
Yeah, sure.
Okay.
Okay. So here it is. I tried to analyze Mexico's confirmed cases in other countries using different criteria. First, I got this table and I searched for Mexico, and I got some trouble since the cases are organized by, and each column is a date. So I tried to modify it in Excel, but I found a way to get the data from the table itself. So I don't have to make an Excel for every country I want to analyze. And I like scatter plots, so I made a lot of them. And this was the first one. And I didn't like this one, so I did this one.
Okay.
So days passed. We can see Mexico jumped from about 1,000 cases in 20 days. And then, I wanted to compare Mexico to countries with similar population. Here we have Mexico with some millions, and then the closer one is Japan, and then Russia and Ethiopia and such, and also compare Mexico's population density, which is P under square kilometer. Therefore, I wanted to get the data from Japan and made some tests, and finally I got it. Japan has many more cases, and I made a function of it. So I just pick the country's name and got it. I made a function, but it just picks one and does not compare. I mean, it's not, how do I say it? We cannot compare we cannot compare two countries. So I made another function with which you can. So here I'm comparing cases in Mexico against cases in Japan, confirmed cases only. And I wanted to see how similar or how different it is with how similar, comparing Mexico with countries with similar population quantities. Then we can see it is really different, but the conclusion I draw from this is that Japan is way closer to China, therefore they started getting confirmed cases about, see,
a month earlier.
yeah, approximately a month of difference, and they scaled like way faster and way stronger. And then I wanted to see, that's the criteria of population, but I wanted to see how it does with density. Because density has to do with getting infected cases and such. And then I sorted by density, search for Mexico, which is about 66. And then I said, okay, Tanzania has a similar population, not so much, but not so different, and a really similar density. Does it has to do with density? I don't think so. And then I compare with Bosnia and Bulgaria. And no, it does not have to do that much. And there's a lot of factors that has to do with getting infected cases. Then I compare with Russia, which is a similar population, and it is not so close to China as Japan was, but they have a really low density, and no, it is really somehow similar, but also different. So no, it does not have to do with population and density, or it has little to do. And then Ethiopia with a similar population, no, it didn't have to do. Philippines, not so much. And then I said, okay, it is probable to have more infected people if your neighbor country is severely infected, such is the case of Italy and Spain. They are really close to each other, and they are infected, so we can see that they have similar graphs. But then I checked Iran. Iran is one of the countries with more confirmed cases up to now. And then I compared Iran to its neighbor countries, which were Afghanistan, Pakistan, Iraq, and such. And there's a curious case. Why does Iran has so much confirmed cases and its neighbors do not have, and they have pretty somehow similar populations and similar densities, but not so much cases? This was a curious case. And also I graphed, there's a graph of India. How does India, having 10 times more population than Mexico and way higher population density, has a similar graph to the one with Mexico? And it's a thought process. It's not so much about the technical stuff.
No, it's fine the way you describe it.
We can draw some conclusions, and in conclusion, I compared a population quantity, population density, and geological location. There has been similarities and a lot of differences, and I concluded that the spread rate has to do with the measures every country takes in order to prevent contagion. It has very little relation to population and density, and in some cases, it has to do with geological location and how your neighbor country is doing. And that's about it.
Thank you. Thank you so much.
Okay.
I appreciate if you fix the, how to say, your team member in the
yeah.
Okay,
sure.
bye. So it make it much easier for me. Just a comment about the geographical location. Russia and China, they are neighbor. Okay, work on your geography. They have borders. They have similar borders. China, Japan is an island, so they don't have even borders together. But there are a lot of Chinese tourists that go to Japan. Yeah. But okay, let's move on. I share the screen. So where we were here.
Yeah, that is mine.
Okay, you want to share your screen?
Yes.
Okay.
Okay, can you see the Jupyter notebook here?
Yes.
Well, I use the same dataset as the other teams. Well, here I have a map with the distribution of the cases, and also this is interactive. I just don't see the, yeah. And well, here we have the size of the radius is related to the number of cases. I just think it's low because, well, okay, here I have the progression of the number of cases, and how the global number of cases have evolved over time, and the number of deaths. What's interesting here is the death rate. What I found is that at the beginning it was around 2%, and well, here I calculated the death rate, and we can see that nowadays the death rate is quite large. And I found, well, it may be due to two reasons. The first one is that the virus is collapsing the health systems in the several countries, and the other explanation may be that the actual number of infected people is quite higher than we thought, and that's why maybe we think that the death rate is around 4.5%, but that's because we are not counting the total number of cases. And here we have the number of new cases of each day. I take the difference of the daily cases. So here we have the daily new cases are increasing. And now I choose 5 countries to compare. US, Mexico, China, Italy, and South Korea. Again, this is the number of cases, but if we compare the daily increase, we have that, for example, China, well, for example, this peak in the number of cases was because they counted them in a different way. Instead of do a normal tests, they use like other clinical testing, and that's why we see this peak. But the important thing here is that the new number of cases is already controlled. We have no new cases in the last part of the graph, but the other countries are, for example, also Korea, which is yellow here. It's hard to see, but it is also not presenting new cases. And the US, it's the opposite. We see that the trend is increasing. And Italy, it seems that it is starting to control the epidemics, because here we see that the new number of cases is already at its maximum, and Mexico, it's just starting. We don't see the growth yet. And well, this is basically it.
Perfect. Okay, thank you, Carol. We appreciate it, the insight. Yeah, that's what's interesting about the death rate. How that changes suddenly. So I'm going to. So this 6,000.
That's me.
Okay, you want to share the?
No, in your computer it's all right. It's just that my internet is really unstable right now.
Okay.
Yeah.
We do that in Teams.
Okay, so I go down.
Yeah. So we actually did a really big graph.
This is long.
Yeah, that one was for Mexico, and we were trying to see. We didn't take out when Mexico was at 0. We maybe should have done that, but we were just playing around with it, and you will see a lot of graphs like that right now, so it's all right.
Okay.
So yeah, we played with it with each one, and even play with all of them. So yeah, so right now we have just big graphs saying for each day how each one of them were, and if we could even see something, and yeah, there are some in some cases where we can see something and we were like, oh, okay, it's all right. Yeah. So there on we go to more specifics, so yeah.
So should I keep going down?
Yeah.
Yes.
So yeah, we began to change things right here. So right now, what we were trying to do in here was we changed it to compare other countries with like who the recover, the deaths, the confirm, and we actually did a lot of those in comparison to Mexico. But what we saw was that well, when we put Mexico aside from China, aside from anyone else, the graph was there was a really big distortion. So we decided to do it with Peru, which was basically more or less how we were going to compare with someone else who more or less started with us. So that's why we started to compare ourselves with maybe countries that just started to have the coronavirus. So that's why you see on the top one we see China and Italy, which more or less, well, they didn't start at the same time, but they both were in the same situation more or less. And and right below it we have it with Peru, and right here, oh yeah, in here we on the top one, on that one we were seeing if it was even if we even care about the state or province that they had. And when this is China, and as you can see, even though China has we say that all China has 81,000 cases, but most of them are from Hubei. So sometimes we are comparing us with all of China, while the cases are actually on Hubei, and everyone else, maybe there isn't even a case. So we were seeing that, and we were like, hey, maybe we should also have the providence in there, because it doesn't make any sense to be saying all of China while it's only on a certain state.
Yes, we noticed that because it seems weird. We created all those functions, and specifically in that province, you can see most of the cases, and you can actually see that some other places in Italy have more cases than other provinces in China. So I don't know if are the extremely I don't know, healthcare system that they took place, so that
it's because of the quarantine that they did, very early quarantine. They quarantined the Hubei very early, so it basically stopped affecting other states too much. So
yeah, right here it's the same graph. We wanted to see it just like that, and don't worry. So right here, so we started to do it the scatter plot only for Hubei, and the deaths, the confirm, and the recover over time. We know that we cannot see the dates, but we thought, well, it's just over times to see how we were doing. And as you can see, the more confirmed there are, the more recovered they will be, and the more deaths there will be. So we were just trying to find that relationship between them, and we even saw that in some of the cases. And Mexico, since it didn't have any province or state, we just put none, and that's basically all of them, all of Mexico. And we were seeing how we just basically started. Well, by the time we downloaded the CSV, we were like at 200 more or less. So we're still going there. We even have some confirmed, and as you can see, we have at that time I think we had 1 death, and we had like 4 recover more or less. So we were seeing, and we were like, yeah, this is gonna go even up. So we were comparing with each other, and we were comparing the deaths and everything. So this is Hubei, and we wanted to see the infected. So in that case, where the ones that we took out the ones that died and the ones that recovered to see who actually was infected. And as we could see, it went up really fast, and then it's going down. So the same way it goes up, the same way it's going down. So we were trying to find how we will record maybe by time, and we did the same in Mexico, but we're still going up. So that's sad, but it's all right. Yeah.
Okay.
And that's all.
Okay, thank you. Thank you for your brief explanation.
Yes, thank you.
So you just, for those who haven't defined their, basically set their team members, please set it so I can.
How can we do that?
I think when you submit, press the submit in OK button, it asks you to invite. Anyone did that? Can you explain, someone? I mean, I haven't done it myself, so.
Excuse me?
In OKPy, it doesn't let you add any more people to the group if the deadline is passed.
I'm coming just. So can you please explain that to your classmate? I mean, okay, this is the deadline passed, but for the one that is not deadline passed, can you tell them the process? I'm coming back in a minute. Okay, guys, sorry for the interruption.
So many of them are saying that you cannot, it doesn't give you the option if the deadline already passed. What I already did is I sent you a message through Remind, just in case. But it seems they already told me how to do it next time,
Okay.
just in case, so that next time it doesn't happen.
But you all did it with the same group that you do the project one, right?
Yes.
Yeah.
Okay, so I'll take care of that.
Thank you.
So let's. Sorry guys, it's taking a little bit like more time. Okay, it's. But I'm not basically giving. I didn't give break enough. So I assume when you need to go, like, I don't know, drink of water, you're just turning off camera and you're going and coming back. So that's why we are continuing. And the thing is, we're not going to have time for the lab 6 activities. So please do that on your own time. Okay, it's already available there. Remember about the homework. Remember about the project 2 checkpoint. Okay. Just then remember. Let's go to the next one. 1, 2, 3, 3.
That is my teacher.
Okay, you want to share or you want to explain here?
I can share. The only thing is that I'm teamed with Carol, but we forgot that this was in groups, so we did it individually.
Ah, okay. So you have two different submissions?
Yeah, but I can share mine.
Okay, so just please keep it brief. So
Yeah, I will keep it very brief.
Okay, thank you.
For example, right here, I uploaded all the files. And in this case, I group it because like my previous partner said, there are like several regions. So for example, China have a lot of regions, United States had a lot of regions. So I group it. I group it all the information in order to get like a general table where is the confirmed dead and recovered. And then I did get the percentage of death for each country, the percentage of recovered people, and the percentage of active. I sorted out to see which are the top 10 country. As we can see, for example, US is a country with most confirmed cases, but with more active cases too. And China, the first country that was infected, right now is practically all recovered. There are like a little bit cases actives and a lot of that, but not as much as Spain or Italy. And in this case, I sorted which are the countries that has more than 500 cases that has more percentage of death. For example, Italy is the first one with 10%. Indonesia, and well, you can see it better in this graph. These are the top 10 with 500 cases confirmed. And the most recovered cases that are need to be equal to 1,000. In this case, for example, China, like I mentioned previously, is the country that has a lot of percentage of recovered people, in this case, 91%. I did the same thing with the most active. In this case, it could be useful because there are 5,000 cases, the condition. At this stage, the disease is spreading very fast, and if the country don't do anything properly, they can infect a lot of people, and this can increase the deaths and have a lot of problems in there. For example, Turkey is actually above US. It has a 97% of infected people of those confirmed. Even though there's not like a huge amount of people, they need to take in consideration in that in Turkey. Otherwise, they could have like a lot of problems.
I didn't get it. Like, what does that 97%?
97% of the active cases that have coronavirus that is still active, that is not deaths or
Okay. Oh yeah.
So there are people that has the virus. And in this case, I forgot to mention, but I also include the WHO region, the World Health Organization region that is in each country, in order to see, for example, which are the correlation between the regions. I removed the outliers in order for better visualization. And in this case, we can see, for example, that almost all regions are here except the European region that has a lot of active cases. Also have a lot of recovered people, but in the European region are the cases where are most active. And in this case, I am comparing the percentage of death and the percentage of the recover. This is very spread, but in this case, we can see that almost all of them are still here, that have a very little amount of people recover, and the percentage of that it's not that high. It's almost between 0 and 5%. And that'll be it.
Okay, thank you. Thank you for sharing your insight.
You're welcome.
Move to the next. Okay. Are you here? Juan Damaso?
Yes, that's us.
You wanna share or?
We still have time?
Quickly, yeah. I just want to finish so we don't, just share or just talk about here.
Because it's very bad, our presentation. Well,
So you can talk when I'm showing here.
Okay, so the first one is just like a histogram, and like well, I'm with Angel. I couldn't put it with a teammate, but he's with me, or I'm with him.
Okay.
And well, the first one is just a comparison between the latitude and longitude of the coordinates, just to show like how the virus spreads. Like, even though we can spread by air, it's most likely to spread by other means, like by water or different methods. So we can see like most of the cases are centered, and that means that like countries in those spaces have more cases. Like I couldn't put the map, but if we had a map, we could see like those centered countries having the most cases. And the other one is just like a histogram to show the big difference between us, just like a little bit of countries that have a lot of cases and lots of countries that have lots of cases. And that means that like every country is starting out. So what we have to take care of is we have to stop those countries like that are in the 0 mark or like over there to become the others in the 1,000 or 5,000 mark. And that's it.
Okay, thank you. Thank you for keeping it short. Let's go to the last one. Oh, okay. I think they are not here. Eduardo Alonso? Okay. So guys, thank you. Sorry it took a lot of time. The class, yeah, maybe I had to basically break the groups in a bigger number so it would be easier. But anyway, thank you. Just I'm going to upload the recording session. Again, I remind you about the deadline. Please check it out in the. You can check them, all of them, in the Canvas. Okay, lab 6. Just check the deadline. It's a Sunday. This Sunday that's coming, midnight. Homework is the next week. So you have almost 2 weeks to do it. And the project 2 checkpoint is also in 2 weeks. So if you have any questions, doubt. Anyway, if you had any question, doubt about doing anything, you can just drop me a message in Remind. We can have an online session together. Thank you guys. See you next week. Have a nice home stay. Bye.
Thank you, teacher.
Bye.